Hello techies, welcome to IT Tech Solution. To continue with the PySpark learning series, today we will see RDD in action. We have already covered the theoretical aspect of RDD in the last lecture, but today I will show practically how we can create RDD and how we can print the contents of the RDD. So let's start with it. So topics in this I will be covering today is RDD recap. Ways we can create RDD. So there are two ways that we can use to create RDD in PySpark from the parallelized collection. Another is from the external data sets. So these two options we will see in practical. So next is RDD basics, right? So what is RDD is, as we have already discussed earlier, it is a resilient distributed data set. So now this data set we'll see when practically we create the contents of it, we can see. It is a fault tolerant collection of elements because the contents of RDD is divided across the cluster and it has the replication and everything in place for it. So it is highly available and it is resilient, and obviously it is distributed because the data is saved across all the different nodes. So we will see two ways to create RDDs: parallelizing an existing collection. The another one is referring the data set in an external storage system. RDD as a whole is very less used these days since the data frame, the structured data frame is now in place. So most of the projects they use data frames instead of the data sets, because there are some advantages when it comes to data sets. We have the structure in it, but as I will show you in just a moment, RDDs doesn't have any structure. It is just like a simple list, but it's distributed. Okay. The next thing is parallelize collection method one. We will see this in practical, but yeah, this is there is a API for the Spark context called as parallelized, and using this parallelized method, we can create the RDD. The distributed data set can be operated on in parallel. As I said, right, it is distributed in number of partitions, in number of nodes, so everything happens in parallel. This also we will see in example how it is processing it in parallel. It gets divided into different partitions. The number of partitions by default it will create as per the data sets. If your data set is spread across the cluster, so each block of data will be saved in a separate cluster or a separate node, and that will comprise of a partition. So if a data set is divided into 10 nodes, it will have 10 partitions in it. But as we read the data from cluster, we can redefine the partitions using something sc.parallelize, as I have shown here, right? This we can control the number of partitions. Sometimes since the data is distributed in nature, we want a specific partition to be created, so we can control that. So this is the way we can do it. And the second method, the external data set. So PySpark can create distributed data set from any storage source supported by Hadoop, and the text file RDDs can be created using Spark context text file method. So this again we will see in practical, and we will see how we can create it. So let's jump and see the practical example of this. So what we can do is we can run this program in the Jupyter notebook. We will launch it. So what you can do is you can simply download the Anaconda. Okay, so Anaconda distribution, if you download, you will get something like this, Anaconda distribution. Okay, so this is the Anaconda navigator. Once you install, it is pretty simple to install. Only one thing you will have to be very careful of is Anaconda comes with its own Python version. Okay, so when we run any program, any PySpark program in this in Jupyter, it will have its own Python version, and the one that we are using in our system should match, otherwise you will get some errors. So if installing, after installing Jupyter, if you see any issues in it, just first thing is to make sure that both the Python versions are same, the one which comes with Jupyter. And how we will check that is, once you install the Anaconda distribution, you can go to Anaconda prompt. Okay, so in the Anaconda PowerShell prompt, you can just check the Python version here. Okay, similar to we do it in our local system, right? So 3.11. So my my Jupyter notebook has Python 3.11. So we'll have to make sure in our system where we are running the PySpark code, it should also have 3.11 Python. Otherwise, these two won't match and it will throw error. and you'll have to then upgrade or downgrade your local Python according to this one. So this is the only thing that you need to take care of. So here now, once you install, you will get list of folders here. You can create a new folder. So you can create a file, you can create a folder here. So I have created one folder here. I'll just go to that PySpark learning series. And in this, I have created the first notebook here, a PySpark create first DD, first RDD. Okay, so here is the code. I will go through each line of code and then we will see how it works. So along with this, if you just try to open the web UI here, the Spark UI, now you will see that it will not get launched because we haven't started our application yet, right? So once we launch the application, we create the Spark context, then only it will start the web UI here. So right now you can't see there is nothing here. The cluster is not up and running for now. So let's start it. So first step is import the PySpark.sql from the Spark session so that we can perform the SQL kind of SQL like operations and all, right. So first thing is this one, we just need to run it. The second cell, it is now creating the Spark session, right? This is the first thing. So once we run this, it will take just like a couple of seconds and then it will run. So now it has completed. My Spark session is now created. Now if I go to my localhost 4040, you can see web UI is available now. But still, there are no jobs, no stages, nothing is there because we haven't run anything. We just created a Spark context. Okay. So as soon as I create a Spark context, you will see this UI. So we are ready. Our Spark session is up and running. We can then we have the access to all the Spark APIs now. So this is what theoretically we saw in the last lecture. So Spark session, it provides the entry point to the Spark. Now we can perform all the Spark operations. Before this, we can't do any Spark operations. It won't be identifying the Spark APIs. The next thing, RDD from parallelize function. This is the first thing. So we'll just provide a list, and out of that list we will just create an RDD and then we will see how that RDD looks like. Okay, so I'll just run this. So it is simple data list where I have given the numbers as list. So that list is now created. Now using parallelize function, right, sc.parallelize, so spark context dot parallelize, and then I'm passing that list of data, so it will create the distributed data set for me, that is RDD. So I will run this. Okay, now I have executed this code as well. Okay, now let's do one transformation. Okay, so now this RDD here is created. Now I will create another RDD. So as I explained last time, that the outcome of any RDD is again RDD. So from this RDD, what we are doing is RDD.map, and we are using a map function, and then we are just all the contents we are multiplying it by 2. Okay, so whatever the contents that I have given here, I'm just multiplying it by 2. Okay, so that is square of each of these numbers I am trying to calculate, and I'll be using a map function. And what is a map function, what is a flat map, all those informations we'll see one by one. So from our basic RDD, we will be getting the square RDD, okay, square of each of these elements. So let's run this. This is the first transformation that I will be doing. So till now, we have run few of the Spark APIs, for Spark commands, but still if you see here, there is nothing, no job has been executed till now. And this is what I was explaining in the last lecture, that Spark follows lazy evaluation. Although we have executed some code in our PySpark program, but still it has not triggered any job or any data transfer or any data processing. So right now what it is doing internally is it is creating a DAG. Okay, and then it is just recording the steps that we are doing as executable. It has not executed it yet. Okay, so that is what lazy evaluation. If we have some more transformations, we still can go ahead and do those transformations, but it won't be reflecting here, or it won't be triggering any data transfer or any of the jobs. Okay, so that way, as many number of transformations we can do, actual execution of job won't happen until and unless we perform an action. So next step you can see is an action which will return us the data. Okay, which will need to fetch the data, like for example collect. So it will bring all the data from the source, and it will then display it on our screen. So this is what is a collect is the action, the first action. Similarly, second action I will do on this second RDD. So first RDD I will be just displaying the data, which is this one. It will display this data, but it will be an RDD. Second action is the second RDD after transformation. I will again do a collect of that. So there will be two actions that we will be doing, and soon after performing we can check here, we will see the jobs and all. So let's perform the first action. It will also display us the contents of the first RDD. So it looks like it is simply a list, but if we just try to find the type of this variable, like for example, I will just print the type of RDD. So this was my variable RDD. I'm just printing the type of it. So if I do a type print of type, you can see that it is RDD, PySpark RDD. So this is RDD and this is distributed. This is not a normal list residing on a single machine or a single node. It is actually residing on multiple partitions. Okay, so this is how an RDD looks like. Now, since we performed the first action, right, you will see there is one action that will be coming here. So now you can see the job it ran. Okay, now the exact job ran, and you will see it running in stages, and you will also see different tasks here. So let's go through this UI, what it all shows. Here it is showing the job here, completed jobs. Okay, and this job is succeeded, right? So all the tasks in it got completed successfully. And how many stages it has? It has one stage. Okay, and in one stage there were 12 tasks. So in my last lecture I explained this, that each of the data that we are reading is in different system or the different nodes, right? Based on that it will create that many number of partitions. So right now when I am reading a data from here, it is treating it as it is reading from 12 different nodes, because my system is a 12 core system. I have a CPU of 12 core. So each core acts as a different node, because this is a single node machine, or it is a local. We don't have actual cluster here. So it will represent cluster in real world, but on my local system, it is treating it as it has 12 number of cores. So it is reading the data from 12 different cores using 12 different cores or 12 different CPUs. Okay, so that is why what it is doing is it is creating 12 tasks. Now if we click on this, it will show us the stage. So we have one stage, and each stage again will have 12 tasks. So we expand this, so it will list down all the tasks here. You see it is 12 tasks now, and these 12 tasks got executed parallelly. If you check, everything was working on the same time, right? 1632 times time, you can see. So all of these 12 tasks were running parallel. Now just imagine when we are processing big data, right? We have millions of rows. So all of those millions of rows will be all processed parallelly and on different nodes. And each of those nodes will have its own number of CPUs and cores. So it is highly parallel. So that is why it is called a distributed data set, right? RDD. And why resilient? Because the data itself is stored on different clusters. So this makes it very clear how the data is internally is being processed. And you can see also the DAG here. There is nothing, only a parallelize function it had to do. So that is how it looks like. Other things, if you check here, it will also show us the different properties here. So if you see the Hadoop properties, all the default PySpark properties are set here. You can just see that all the Spark properties, all the Hadoop properties, the resource properties, everything you can see here. You can see the details of executor. So right now it's just like a single executor, since it is a single machine. So it is showing me a single executors, and each executor has completed 12 tasks, right, for 12 partitions, and what is the time it took and all those things, we details we can check here. So now first action we ran, we will, that is why we are seeing only single job, right? Let's do the second execution, second action. So now second action, I just want to print the squared RDD, right? The transformed RDD. So let's run this. Now you see the result it's showing me is the square of all of these. So 2 multiplied by 2 is 4, 3 multiplied by 3 is 9, 4 multiplied by 4 is 16. So this is the square of the input RDD or the input data set. So this way we can do some transformations and then display the result. Now this is, since this is very small data, right? We are doing a complete collect. So on real cluster, we should not do a full collect. It will try to fetch all the records from the different nodes and bring it to the driver program, and it may result in out of memory of the driver program. So there are other actions or other methods we can use to sample the data. We should not pull the entire data. Now, as I was saying, we can see that there were 12 partitions, right? Let's check the number of partitions here in this code. So in the first RDD itself, I'll just try. This is another API that we can use to get the number of partitions. It is get num partitions, right? So let's just run this. It says it has 12 partitions, and I said, right, because of 12 cores, it is processing all of those in 12 partitions, and then using it, it is creating 12 tasks. So this way we can check the partitions in it. Now we should not do a collect of all the data. Instead, there is an API called as take of 2, take of 1, or maybe take of 5. We can just sample data, few set of data, and then we can if you want to check or validate the data, we can just do this. So now I'm just pulling two records from it. Similarly, we can, there is one more action called as count. So by the way, as many transformations we keep on running, right, we will be seeing that many number of jobs coming in here. So earlier we had only one job. Now you can see we have four jobs because we ran four actions, and all of these actions will show you how many tasks are there, how many stages it got divided into, and we can also check the DAG. So here is the DAG for my second action. So second action, we had two transformations, right? One was creating the RDD, simply RDD. Another one was some transformation, and then we collected that data. So we will see that there are two blocks here. Okay. So similarly, there is count. If we run the count, we will see how many count of the records are. We can also do simply rdd dot first. It will just give us back the first record. So this way we can do. The last action we can do is we can save this RDD whatever we got. Suppose we want to save this square RDD when we did the transformation. Now we are happy with the result. I have just checked all the sampling data. Now I want to save this as a file, okay, on my root folder. By the way, we can give the complete path here, but since I want to save this file in this root data itself, root folder itself, I'll not give the complete path. So if we run this, I'll just simply run this. It will write the files in my first RDD folder, and it will have that many number of partitions in it. So if you see the first rdd.txt, I gave txt, it should be just first RDD because it is a folder. And if I see here, it created all of those records in different partitions, 12 partitions. I'll go to 2. So here you can see I have a record as 1. Okay. Similarly, if we go on displaying everything here, we will see that it has some or the other records in it. And all is divided into these many number of partitions. So this is, since it is a very small data, everything got divided into different partitions, and we can see the data is there in all of these divided into different files. We can control these things. As I said, we can control the number of partitions so that the output files, number of output files can also be controlled. So in this way we can write that data into a text file as well. Now the second thing is, let's try to read data from the file. Instead of using sc.parallelize, we will try to read it from the file. So what I have done is, again in my root folder, I have created a sample file. I have some data like this, okay. So it is 6 records, and each record is having two fields in it. And let's try to read this file and display the contents and see how RDD is getting created in this. So now the function that we can use here is Spark contexts text file. So this text file API will create the RDD from the text file, and the text file we are providing here as a path. So this again can be a complete path, but since it is in the root folder, I just am giving the file name here. So now let's run this. Let's define the path of the file, the name of the file in file path, and then the second one is using text file. I'll create the RDD from this file which I have defined in this path. So that I can run here. Okay, now this is executed. Now let's print the type of this variable. Let's see whether it is RDD or what exactly it is. So you can see that it is RDD. So we were able to create RDD from this path. Now this file path can be any external file, any of your Hive files or your S3 files or HDFS files, all those things we can provide here, and we can create RDD from that. Now, since this is created as RDD, now on this RDD you can do any type of transformations such as filter or select or do some map, flat map, all those things we can do on top of this RDD, and we can get in return a separate RDD, I mean next RDD. And final result you can again save it as a text file or maybe as a sequential file, and we can then do a collect here. Again collect I'm doing, but we should not do when we are working on the big cluster. So here you can see I have displayed the result here. Now again, if you just check the jobs here, you will see that again there will be more number of jobs which is completed here. And this is the way that we can create the RDD. So that's all about creating RDDs. In next few of the lectures, we will see the different types of transformation that we can use on top of RDDs, and we can see how we can make use of all those different actions and different transformations. So that's all for now. I hope you liked the video. If so, please subscribe so that you don't miss the future lectures on this learning series. Until then, have a nice day. Bye bye.